Good evening, good morning, good afternoon, depending when you're watching this. I'm Matthew Polinsky with Manitoba Tech Transfer Program. We're called the Knowledge and Research Transfer Program, and we operate under the Manitoba Beekeepers Association. Tonight, we're hosting a webinar with 4 invited guest speakers. Topic is, of course, oxalic acid glycerin in Canada, efficacy, expectations, and IPM fit. So tonight we're going to hear from Lynae Ovinge. Lynae is a researcher at the University of Lethbridge and also runs a consulting company working with beekeepers across Alberta. Next, we'll also hear from Dr. Nuria Morfin from the University of Manitoba, assistant professor of entomology. Laurence Plamondon from Quebec. Laurence is a project manager at the Deschambault Animal Science Research Center, and Alvaro de la Mora Peña. Alvaro is a postdoc at the University of Saskatchewan at the Western College for Veterinary Medicine. So before we get started tonight, I just wanted to say thank you to all of our collaborators who are putting this out on their YouTube channels. It is on our KRTP channel, the Manitoba Beekeepers Association, Red River Apiarist Association, on the channel of Nazari Diakev. He's a local beekeeper here, on the channel of Ian Stepler, and on the channel of Brad Hogg at That Bee Man. And Brad is also providing tech support to run the show tonight, so a special thanks to Brad. So to get us started, I'm going to talk about oxalic acid usage and dosage, just kind of setting the background for all this other stuff we're going to hear from later on tonight. And throughout my presentation, I'm going to kind of set up what we're going to hear about from all of our other speakers. So just to start off, I wanted to say that tonight's content is pretty specific to Canada. I know we might have a lot of people tuning in from around the world and from the United States, but there's a few reasons why it's specific to Canada. Of course, unique climate and beekeeping conditions in our different regions, the seasonal progression of our season, our production objectives, but especially the pesticide registrations and restrictions here in Canada. One of the reasons we're putting this on tonight is that oxalic acid glycerin application is finally registered in Canada for the first time for use in 2026. So we're going to be trying to get the conversation going on that. And yeah, so one of the things we want to do is review some studies, but those specifically done here in Canada. So as I mentioned, this is new to Canada, oxalic acid. We've been using for a very long time, but the oxalic acid in a glycerin formulation is what's newly registered. So this will be the first year that Canadian beekeepers can purchase ready-to-use products and make their own products at home legally and use it in their colonies. So we're going to talk tonight about both the ready-to-use products and the homemade do-it-yourself label. Just to get us started and I got a little bit of information from those attending the webinar. I asked a series of questions about how familiar people are with this. Out of the 62 responses, we had 41% saying that they feel confident and ready to treat with oxalic acid glycerin this year, whereas 60% were not saying that they were ready. 34% were somewhat, and 24% said no, they don't feel certain at this stage how to use the product. So I asked what type of product people will apply. Will they buy a ready-to-use product, or will they make their own, or not sure yet? This one actually surprised me. We had 56% of the 62 responses saying they're undecided if they're going to actually buy a product or make their own and then put it into their colonies. So that's a whole other topic of the fabrication and making of the product, but it shows that there's a bit of uncertainty about how to address going about this mite treatment. I asked, how do you feel confident in preparing your own oxalic glycerin treatments this year? 30% of respondents said yes, they feel confident in making their own treatments with the do-it-at-home method, your homemade method. 40% said somewhat, I could use more guidance, and 32% said no, I'm largely uncertain and inexperienced at this stage. I asked what level of control do you expect from it? I'm not sure what to make of this one. I think we'll learn a lot more through tonight's presentation. But 24% thought they would get a high level of control from oxalic acid glycerin treatments. 63% thought medium, and 12% thought it'd be a very low level of control. So I'm really looking forward to hearing from our presenters tonight, some of the studies they've done, looking at efficacy and other impacts on colonies to see what we can learn. So again, these are our two options here in Canada, registered for use this year. For those who are kind of unfamiliar, glycerol or glycerin, it's a moisture retainer. It's been used as a preservative, a sweetener, thickener. It's used in a wide variety of food beverages. So that's kind of the origin of it. But how did we start using this to mix with oxalic acid and then treat our colonies for Varroa mites? I just want to briefly touch on the development of this treatment. There was a lot of really notable research that came out of a research group in Argentina with the first published papers in 2016 by Matthias Maggi and his group there. Over time, there's been a lot of universities globally who have tried out these glycerin methods and published on it. Aluin-Cap is a company based out of Argentina, and they've also done a lot of work on developing the product, developing this application method. Vita Bee Health is the maker of Varroxan, and that's the one we'll talk a lot about tonight since it's the product registered in Canada. They've done trials in Greece, in the United States, and all over the world. So they have a lot of data, a lot of information on that. I think a lot of you are really familiar with Randy Oliver. He really popularized the do-it-yourself method in the US, and he's published a lot of that on his website, and the American Bee Journal presented on that. Multiple universities in the US have looked at this as a treatment, but today we're going to be focusing here on efficacy trials in Canada. So to my knowledge, and there may be more, but there is record of two trials on glycerin treatment in Quebec, one of which we'll have be hearing about tonight. There's two from Ontario, again, one of which we'll be hearing about tonight. And there's been two ongoing in Manitoba and in Saskatchewan. And I'm involved with the two in Manitoba in collaboration with Alvaro, who's going to be presenting about some of the work that he's doing in Saskatchewan. So we're partially working together on some of that. So what do we have? Here right now, we have the ready-to-use product. It's the only ready-to-use product registered in Canada. It's called Varroxan. It's made by Vita Bee Health. There is another one that's popular in other parts of the world called Aluin-Cap, but that's not registered here in Canada. The other option is using the homemade method. So you'd be mixing the glycerin and the oxalic yourself, and then having it absorbed into either a cardboard strip. There's other common materials that have been used, such as a Swedish sponge, a maximizer pad, fiber paper, and in the past, shop towel was quite common. It seems to have maybe tapered off in use these days. So we're lucky to have with us tonight Lynae Ovinge, who has worked a lot as well on understanding the homemade methods. So she'll be here to tell us about that. I just want to give us a quick context, probably about 2 or 3 minutes, talk about oxalic acid in general, and just get an understanding of why it's so different with this new glycerin application. So we have the dribble trickle method, vaporization, and now we have this slow extended release method, which I refer to as OAG. So the methods of doing the dribble, It's typically a single application, but there is research ongoing on repeated applications, understanding if it has any impacts on the colony, negative impacts. However, in general, it's very easy and safe to apply. You mix it in a sugar solution. It's been proven effective. It's optimal when broodless. And the label dose is 1.75 grams per application. With the vaporization method, it's proven highly effective. You use multiple applications. You do need special equipment, the respirators. You want to be very careful around that. It is optimal when broodless or near broodless. Again, it can be used at other times when there is brood, but it doesn't kill any of the mites under the cappings, and that flash style treatment doesn't hang around very long. So it is better when broodless or near broodless. The label dose in Canada is 2 grams, but the common dose between beekeepers these days seems to be around 3 to 4 grams per single brood chamber. Now, with the extended release method that we're going to be diving into tonight, again, as I mentioned, the carrier would be cardboard or a Swedish sponge. It's a single application for 42 to 56 days. This is typically done in the presence of brood, but it could also be applied, I believe, as per the label, without much brood. It is very easy to apply. Again, this is in contrast to the vaporization method. And at each application, you're putting on 28 to 45 grams approximately of oxalic. So it's a slow, continuous release. It's a single application. So just a quick review. We have the dribble, 1.75 grams of vaporization, a flash treatment. That's 3.5 grams approximately, seems to be a common dosage among beekeepers. And with the glycerin, the label dosage is approximately 30 to 40 grams, depending on the size of your colony. It's a single application, so it's a slow release, and it's going over that 6 to 8 week period. So it's quite different than the prior ones. With the ready-to-use strip, there is 7 grams of oxalic per strip. You put 1 strip per 2.5 frames of bees. So for a 10 frame Langstroth box, you would use 4 strips, and that equal 28 grams for that single brood box. Again, 42 to 56 days, and it is approved for use with honey supers on. So I think that's one of the really interesting things about this new method that a lot of people are excited about, is that they're able to use it with honey supers on. So just in comparison now to the homemade label and recipe, it's the same pretty much. It's also 42 days, but the label says 40 grams of oxalic acid per hive, single or double brood chamber. Okay, so single or double, you'll put on 40 grams per hive, whereas with Varoxan, you'll put on 28 grams per single brood chamber. And as per the guidance of the company and the label, you wouldn't exceed 42 grams in a double brood chamber treatment. So you wouldn't put on 8 strips. As per the label, you would only put on 6 strips. So it'd actually be a total of 42 grams for a double brood chamber. So that's where these two label instructions kind of level up. They both indicate that you shouldn't be exceeding 40 grams per colony. So coming back again to the point of this, or the impetus for this presentation tonight, we're here to talk about its use in Canada. Now that it's registered, it's kind of an open discussion on the best practices and adaptations to local conditions. So I meet with our beekeepers here in our province, and we try to share information. So it's all about talking on the learning curve, and trying to learn as fast as possible to make this a good tool in our toolbox. Another thing that we want to focus on is, learning from the research that's already been done in Canada. So that's what we're going to highlight tonight. Over the past few years, we've heard a lot about this treatment. There are various claims from beekeeper experience and also from the companies. So lots of different beekeepers have reported here in Canada and globally different preference for the materials that they apply, different levels of efficacy depending on their region. It's been called extremely beneficial to the health of a colony. So keeping those mite levels low, I guess, is the assumption there. Trials demonstrate up to 95% efficacy according to some of the labels. So we're going to talk a bit tonight about the Canadian summer studies, and from my understanding, most of them have showed kind of moderate control, but we're going to hear from the researchers themselves. In general, what I've heard at least is that beekeepers report moderate, reliable control from oxalic acid glycerin treatments under relatively low mite pressure and with well-timed applications. So there seems to be a mix of expectations, and there's a lot of different environments, different colony statuses, and different even materials that we can apply this treatment on. So I want to have a better understanding for myself. What can I expect when I'm using this product? Some of the considerations that are going to come up tonight with both of the homemade and ready to use are the material preference, fabrication consistency, human health, field handling, but also the fabrication process, the convenience of purchasing it, but maybe also the trade-offs between application, whether you're using a strip and you got to get that down in between your combs, or you have a pad that you're laying on top. Again, new summer treatment, that's a really important thing to highlight. Surface area versus exposure time in the hive, general efficacy and cost of benefits. Some of the things that may also come up and then have come up in conversations with beekeepers is kind of research to be done, observational learning to do while you're out in using these products, and maybe some caution in current practice as we learn more for our current regions. So is there any potential impacts on brood patterns or colony size? We've heard from beekeepers that there could be potential overdosing in some cases, and especially on smaller colonies. The big question globally is always, can resistance develop with long exposure periods? And the simple answer that I've come across time and time again is that rotations remain really critical. You can't be relying only on one active ingredient. There's been no sign of resistance to oxalic acid so far, but who knows what's possible. Strip avoidance. So I've heard that from some regions where the cluster might avoid the strips a little bit, especially maybe when that cluster is obviously smaller and is able to avoid the strips. So just being sure not to miss treatments on smaller colonies. There's been no indication yet of significant impacts on queen health and honey production, but it's something I think to keep an eye on and to look out for new research on. And again, looking at our seasonal timing so that we can get an efficacious product and still reach our production objectives for the season. There's another study that I sometimes mention that was presented at Apimondia. Then it was looking at the impacts of a prolonged exposure to oxalic acid glycerin on bees at the colony level. So what they essentially found was that oxalic acid glycerin was activating their immune system in some way for prolonged periods of time. And they weren't sure if that was a good thing or a bad thing, but they noticed some change in the bees, and they were continuing their research on that. So there's lots of things upcoming. So just always stay tuned. I just wanted to mention a recent webinar that the Canadian Honey Council, Canadian Tech Transfer Programs, and Veto Pharma put on, called the Bee Health Webinar Series. And within the first day, we had a presentation from Vita Health Bee, Vita Bee Health, who produces, the Varroa strip. So in this presentation, their technical director gave extensive information and directions on how to best use their products. So I think it was really great information, and I recommend it. One of the takeaways that I have here sharing from his presentation is a really what they call a classic mistake. So what you see in the first 3 photos is the way that they do not recommend placing the strips. Whereas on the far right, you'll see the way that they recommend placing the strips for maximum efficacy. So really simple stuff, but I think a lot of things can happen out in the field, and we have a lot of ideas. This is the recommended way. So based on the recommended label way, you can expect that they've tested it and they've have some data to back that up. So I encourage everyone to go and check that out. I put a link to that in the video description. If you're watching this on the KRTP channel, there's a number of video links to relevant material to tonight, and that's one of them. Yeah, I guess one of these links is not live yet, but the other link is live. You can do a product label search on Canada's website to find the exact instructions, especially for that homemade version of the glycerin application. Whereas with Varroa, it's also actually on the product that you buy. And before going forward anymore, I guess I did want to mention another link in my description on the KRTP channel is to a webinar that I put on last year with one of tonight's presenters, Lynae Ovinge. And what it is called was How Beekeepers Can Do Research, finding practical solutions in your operation. So this year, as you're out and you're trying new things and you're perhaps trying this glycerin method, if you want to be able to maybe have more confidence in understanding, did this work or did this work, or did I have the right mix of control groups and things like that. What Lynae explains in that presentation is how to set up an experiment design so you can actually find these answers out for yourself in a reliable and rigorous way without being too labor intensive either. So I encourage anybody who wants to experiment and try to find those answers out for themselves to check in on that. So tonight, I know my intro was quite long, but I think we kept everybody's presentations actually fairly short. We wanted to draw on from every other province that we could, different regions where this was tested. And I hope I set a little bit of the context for what we're going to be talking about. So I'm going to invite Laurence Plamondon to the screen, and she's going to be talking about her study that she conducted in Quebec. So thank you. And I guess I should mention, if I'm still on, that we will take questions at the end. So maybe hold some of your questions till the end, if they aren't answered during the presentation, you put them in the chat and we'll address them at the end. Thank you.
Okay, thank you. So, hi everyone, I'm Laurence Plamondon. I'm project manager in the bee team at the CRISAD in the Quebec province. And the presentation of today is about my master project on oxalic acid and glycerin pad, of course, during 2021 to 2022. So we're going straight to the point. The treatment that we used was a homemade. So we use a kind of felt pad, which was a mix of viscose and polypropylene. We buy it at the Dollarama, which is kind of the dollar store. I think you have the same thing in the rest of Canada. And we put those pads on the top of the brood chamber, right under the queen excluder. It was 20 centimeter by 20 centimeter. And we also add an opening in the center to facilitate the movement of the bees through the honey super. In the mix, we add glycerin, water, and oxalic acid. Each pad add 30.5 grams of oxalic acid for a total of 27 grams per colony. So this is less than the new homologation of homemade pads, which is around 40 grams per colony. So keep that in mind during the result. So the objective of the project was to measure the efficacy of that new treatment, to compare it to the Formic Pro, and then to evaluate the effects of that summer treatment on the colony. So we had 3 groups. First one was the control with no summer treatment. We also had the Formic Pro with formic acid, and then the oxalic acid pads. And we apply those treatments for 3 weeks from 2 August to 23rd August 2021. And just want to say that this is less than the new homologation, which recommend 42 days. So for the project, we had 135 hives in 6 apiaries in 3 different regions of the province. So we had the research center, and we also add 2 commercial beekeepers to the project to have more hives. We measure different variables. First one was Varroa drop on sticky cardboard each week, so during a 7-day period. We also look at the bee population and cluster size. We also look at the brood population, the dead bees in front of the hive, the weight also, which can be kind of interpreted to honey harvest, sorry. And we also took samples of honey and viruses. So let's go to the result. Sorry. So first one, this is the daily Varroa drop during all the project. And first result is during the summer treatment. So at the beginning of the application of the experimental treatments, you can see in green the control group, in purple the formic acid group, and in orange the oxalic acid group. And what we can see is that only the formic acid group had a higher daily Varroa drop, but not the oxalic acid pad. Then when we look at the end of that summer treatment, we can see that only the formic acid group had a lower daily Varroa drop. So this is quite surprising, but let's look at the other result. At the end of the summer, only the formic acid group was under the threshold of 3% of infestation. But then, when we applied her control treatment, which was the ApiWar, we wanted to know how many Varroa there was left in those hives. And we can see that in orange, in between, the oxalic acid group had significantly less Varroa than the control group. So even if during the summer treatment there was no augmentation of daily Varroa drop, there was still less Varroa left in those hives. So this is very interesting. And then the next, in spring, Varroa drop was similar between groups. And then when we look at efficacy, just want to mention that the calculation of the efficacy is the experimental treatment mortality divided by total of experimental treatment mortality plus the ApiWar treatment, which was the control treatment. So you can see that the formic acid had a better efficacy, but oxalic acid was also different than the control group. So even if it was less efficacy than the formic acid, it was quite better than the control group. And I want also to mention that during this year, there was a lot of Varroa in Quebec. And so even if it's only 40% of efficacy, or even less, there were thousands of Varroa on those sticky cardboard. So it was quite efficacy, even if it don't seems to be. We also look at the hive weight. So the change in hive weight before and then after the treatment. And we can also see in orange that the oxalic acid group had a lower honey hive weight. So yeah, we can interpret this that oxalic acid had quite reduced hive weight gain during our project. So, and then when we look at winter mortality, you can see that the oxalic acid treatment in orange was in between the formic acid and the control group, but not significantly different than the control group. And during that winter, Quebec mortality was of 48.4% in the province, just to give you an idea. So kind of reduced, but this was not significant. And then were the pads 3 weeks after the application, just to give you an idea of what it looks. And this one also to specify that the new emulation is 42 days, so it can be quite different of what you will observe in your hives this summer. So in conclusion, the efficacy was really variable, but significantly different than the control group. So it had kind of moderate efficacy, and there was a significant impact on hive weight. And I didn't present the result to fit in the 10 minutes, but there was no impact on brood and bee population, which is really great. There was also no residues in honey and no impact on viruses. And then for winter mortality, it was less than the control group, but not significantly different. And all those results are in a publication, which is free online. So if you want to check and have more details, you can go. And I want to thank you, everyone of that project. And I will say that the next presentation is from Nuria. And have a good night.
Well, hello everyone. I'm glad to be here with you. Thank you so much for the introduction, Laurence. And I will present about this study on the efficacy and safety of oxalic acid and glycerin for Varroa control. And I would just like to mention that my involvement in this project was related, I guess it started 2 provinces before I settled in at the University of Manitoba in Winnipeg. So I was working and living at the in Guelph, Ontario, and I had the chance to collaborate with the Ontario Tech Transfer Program. And in this particular project, I was involved in analyzing the data. And along with Lynae, we wrote the manuscript, which is now published in an open access journal. So that means that if you Google it, you'll find it, you'll be able to access this study. And in a rainy day, you can have a lot of fun seeing what was some of the details and things that happened throughout this study. But today I will summarize the findings and some of the things that are relevant for on the practical point of view and management for Varroa control using this oxalic acid and glycerin formulation. So this study was based on the previous projects that were conducted in Argentina. As Matthew mentioned before, these were done by the group of uh, Maggie et al. And so you will see that the doses and the formulations are following their initial study in those regions. And the idea, as you might suspect, it was about ways of better controlling Varroa destructor. This study, I guess I see the years, and it has been a while since this study happened. But the things that has remained the same is the impact of Varroa destructor and its relationship with overwinter colony mortality. Varroa is still a concern, and very recent studies, one of them conducted in British Columbia, we showed that colonies with 1% or more mite infestation during the late summer or fall are more likely to die in the following spring. And this is in line with another study that was conducted in Quebec, where they found very similar results and an injury level of 1% in colonies that were parasitized by Varroa, with this percentage equal or more of 1% mite levels, and also infected with deformed wing virus. So we're seeing that this threshold that we have, this limit of Varroa levels that we have, to have a more likelihood of success, of overwintering success, it comes to 1%, which is, so that means that we need to include different tools and management practices to make sure that at the end of the summer or fall, we have low levels that will allow us to have better success. So that comes with a challenge because when this study was conducted, the one that I'm mentioning right now, that was done in Ontario, there were few registered products to be used in the summer. And so we basically had a formic acid, then later a Hopguard, and now we have oxalic acid and glycerin. And there's two options that it was mentioned before: the homemade approach, the do-it-yourself, or the commercial product Varoxan. So this idea of having a treatment to control mite levels during the summer was of great interest to the beekeepers, and also to have proof or data to support the registration of such products. So the main objectives of this study were to evaluate the efficacy of oxalic acid and glycerin to control mite levels during the summer in continental climate, that means Canadian conditions. And also to compare this formulation with other registered treatments, including oxalic acid triple and 65% formic acid, and all these applied during the summer period. And then the third objective was to assess treatment effects on bee cluster size, worker mortality, brood pattern, queen status, and colony survival. And lastly, there were some honey samples taken to make sure that there were no residues of oxalic acid in treated colonies. Again, emphasizing that this treatment, the aim of this treatment was to be applied during the summer when honey supers are on. So for this study, there were 116 colonies included in the final analysis. They were in 3 different apiaries in the Guelph region. There were the colonies were single brood chambers. The study started in mid-August, where the daily conditions were between 20 and 34 Celsius. And this study lasted for 42 days. APVAR with the chemical amitraz was used as a finisher treatment after the 42 days of oxalic acid exposure were done. For the treatments, there were 4 treatment groups. The first one is where the oxalic acid and glycerin strips. The group used cellulose strips to impregnate oxalic acid and glycerin with a final concentration of 10 grams of oxalic acid per strip. So that means that at the end, the colony had 40 grams of oxalic acid per colony. Then there was the oxalic acid dribble, following the label's instructions. 65% formic acid was the third group, and then the control that received no treatment. All of these colonies at the end of the study received Apivar, as I mentioned before, as a finisher treatment. So that allowed to analyze the data, compare the experimental groups against the control, but also the before and after treatment situation. So this is an image of the cellulose strips that were impregnated with oxalic acid and glycerin. They were 24 by 4, each of them, as I mentioned before, with 10 grams of oxalic acid, and they were hung over the top of the 4 frames vertically and left for 42 days. Very briefly, the results from this study showed that oxalic acid and glycerin had a 55.8% efficacy, which might not be extremely high or compared to other studies that showed more than 90% efficacy, but it was significantly higher compared to the control and also compared to formic acid. Oxalic acid, glycerin, and oxalic acid dribble were not different between them. There were so oxalic treatments were not significantly different. And I guess something to highlight is that the maximum efficacy in one of the experimental colonies was observed with the oxalic acid and glycerin treatment, which was 85%. At the end, all the treatments were better than the control, and we will go back on how this reflects on management and the impact for beekeepers. Other results that might be relevant include that the cluster size was not affected by oxalic acid and glycerin. The same for worker mortality, so very similar to the study that Laurence mentioned. There were some traps placed at the entrance of the hives, and dead bees, adults, and larvae were recorded, and there were no differences found between the control and the treatment groups. The same for queen status. So this was a subjective ranking. So the observer went, assessed the queen, and anything related to not good performance, for example, signs of supersedure, spotty brood pattern, more than 1 egg per cell, anything related to the queen performance was recorded, but there was no significant difference between the proportion of colonies with unsatisfactory queen status between the treatments and the control. For brood pattern, there was some effects of oxalic acid and glycerin observed, but the researchers also found a recovery by day 45. So there was some effect on the brood pattern, but there was also a recovery, let's say 2 worker cycles after. And the same was noted for formic acid treatment. So there was an effect or a negative impact of oxalic acid on brood pattern, but there was also a recovery days after the treatment. For colony survival, there was no difference in the proportion of dead, alive, or weak colonies between the control and the treatment groups, including oxalic acid and glycerin. So no impact in most of the variables that were analyzed. As I mentioned before, brood pattern was the only one that effects were noted, but also with a recovery 45 days after treatment. So if we can summarize what the implications could be, we found that the efficacy for oxalic acid and glycerin in continental climates, which means Canada, was lower compared to other studies. We found an efficacy of 55.8% compared to other studies that found close to 90% or more. So there might be an effect of climate and the conditions, just the environmental conditions that could be affecting the efficacy. There are few studies that have been conducted in Canada, but one of them was done at the University of Guelph, and it was done during the fall. And they used cellulose strips as well. The dose was 6 grams of oxalic acid per strip, and they found a higher efficacy, a little bit over 70%. So the effect of the treatment between the summer and fall might be another consideration. If you see other studies done in other parts of the world, in other conditions, it seems like fall treatments tend to have a higher efficacy compared to summer treatments. However, even with that lower efficacy, oxalic acid and glycerin still outperform other treatments like 65% formic acid. It was not different to the dribble method under the same conditions, and this could guide us to use this treatment, oxalic acid and glycerin, as part of an integrated pest management program, not like a standalone treatment, not like the only treatment, but as part of an integrated pest management. We would have to emphasize monitoring for mites before and after treatment. Never trust mites. So I would say once the treatment is over, monitor and consider your fall treatments as well. Because even with a 50% reduction and limiting that exponential Varroa population growth, there's still a risk of having high levels at the end of the season that could impact colony survival for the spring. What else? I guess I cover all that, mainly climate. It might be an issue, fall versus summer treatments, even though there is not a spectacular efficacy, it is still very valuable to be used in an integrated pest management approach. And so I was looking at my photos and trying to find one where most of the people involved in this project were there. And I guess this is a photo that most people that were involved in this project appear. So this was led by the Ontario Beekeepers Association Tech Transfer Program. And there were many other partners, including Canadian Honey Council, Ontario, the Government of Ontario, University of Guelph, Bosworthy Solutions, and University of Manitoba. So many people involved, and hopefully this would give some information and resources that could be practical for beekeepers and the application of these methods. So thank you so much for your attention. Thank you also to the organizers. And the next speaker in queue is Dr. Alvaro de la Mora, a postdoc at the University of Saskatchewan. And thank you so much.
Thank you so much, Nuria, for the introduction. Hello, everyone. Today I will present the results of this project that has been conducted at Dr. Sarah Wood's lab at the University of Saskatchewan and in collaboration with the Knowledge and Research Transfer Program in Manitoba. So, for this study, we wanted to assess the efficacy and safety of the new formulation of oxalic acid glycerin strip, Varroxan, the one that Matthew spoke earlier, but during the winter in Western Canada. First, I would like to thank my lab mates, also all the sponsors, including Vita Bee Health, and the beekeepers, 2 in Saskatchewan, 1 in Manitoba, and also to the Tech Transfer Program in Manitoba for this collaboration. So, as Matthew mentioned, these are the strips that we are using, Varroxan, which are cardboard strips with oxalic acid and glycerin. And this product was just registered in Canada. So this is good because beekeepers have more options to fight Varroa. And we wanted to know how is the efficacy and the safety of this new formulation for the colonies in the winter. Why in the winter? Well, because of the life cycle of Varroa destructor. And the climate conditions in Canada, in the winter, there is few brood inside the hives. So Varroa reproduces in the brood, and by having less brood in the winter, most of the mites are infesting adult bees. So it's a great opportunity to attack those mites that are on adult bees. And in this presentation, I am just summarizing some of the main results after 2 years of this study. So we had different setups. So colonies were under different conditions depending on the beekeeper and the facilities that we had. We had colonies that were kept indoors. These were done in Manitoba and in Saskatchewan, and also colonies that were kept outdoors in Saskatchewan. And this, for these 3 locations, one in Manitoba, one in Saskatchewan, indoors, both of them, and one outdoors, were done at the end of last winter. In addition to that, the second year, we did that at the beginning of the winter. So for the first year, we did that from January to March 2025. And for the second year, we changed the date of application, started in November and finishing in January. For the first year, the colonies that were kept indoors, we had 4 treatments. So we had sham, which was a negative control, the strips without any chemical on them. We had amitraz as a positive control, and 3 different doses of the oxalic-acid glycerin strips. The recommendation dose for a single brood chamber is applying up to 4 strips. So that was our highest dose. Then half of that was medium dose, and a quarter of the high dose was only 1 strip, which was our low dose. For the colonies that were kept outdoors, we had only 3 treatments. So sham, amitraz, positive control, and the high dose of oxalic acid glycerin strips. The following year, the second year, we had colonies in Manitoba indoors, same conditions, but in Saskatchewan, we have colonies kept outdoors. So that was the difference. So to assess the efficacy, we monitor the mite levels on Varroa, on adult bees, and also the mite fall using sticky boards placed under or at the bottom of the hive. And for safety, we assess cluster size and colony survivorship. For the purpose of this presentation, I am presenting only infestation levels on adult bees and colony survivorship by spring. So in the first year, the mite infestation levels in this graph, you can see the 3 locations: Manitoba, Saskatchewan, both indoors, and in the right, Saskatchewan, colonies kept outdoors. And I am presenting here the percentage of infestation. So we can see that at the beginning of the study, in each of the locations, the mite infestation levels were similar. So we started with similar conditions between the different treatments. And the conditions between each beekeeper were different. So that was good to see the effect under different conditions. So after 8 weeks that treatments were in hives, so we have the results. So in green color, we have the infestation levels in the sham group, then amitraz, and the 3 doses of oxalic acid, low, medium, and high dose. With these results, we can see that colonies that were kept indoors Amitraz and the medium dose and high dose of oxalic acid had lower mite infestation levels compared to sham. We didn't see any effect on the mite levels in the colonies that were kept outdoors in Saskatchewan because that beekeeper did a really good management and we didn't have enough mites for this project. So that was good for the bees, but not good for the project. What is new in this presentation are the results of this year. So in this slide, you can see two sets of graphs. One in the left represents to Manitoba, and the one in the right represents Saskatchewan. So in each of the locations, we can see that all colonies started with similar mite infestation levels between the different treatments. And after 8 weeks of treatment, we can see that in Manitoba in the left, Amitraz and the medium dose and high dose of oxalic acid decreased the percentage of infestation. These results were similar to the results that we observed in the first year. And in Saskatchewan, all the treatments, including the low dose of oxalic acid glycerin strips, decreased the mite infestation levels compared to sham. So these results indicate that this product is effective against the mite. And as Nuria mentioned in her presentation, all the treatments after 8 weeks of application had mite infestation levels below the threshold, which is 1% in spring. Then for safety, we assess the survivorship. So for the first year, we can see, I will show the 3 locations, Manitoba indoors, Saskatchewan indoors, and Saskatchewan outdoors. And we can see is the percentage of the survivorship. And in both locations where colonies were kept indoors, the 3 doses of oxalic acid, even or including the low dose, have a reduction of the survivorship by spring. We were not expecting these results because only with one strip, the survivorship is lower. We didn't see any effect on the survivorship, even with a high dose in colonies that were kept outdoors. Those colonies were super strong. So after looking at these results, we wanted to see, okay, what we can do different for the second year that we did the experiment. So what we modified was the time to apply the treatment. Instead of applying the treatments in January, we started the treatments in November. And also for the colonies in Saskatchewan, these colonies belong to the University of Saskatchewan. And the first year, those colonies were not as strong, not as strong as ideal. So the second year, we really pushed to have stronger colonies, and we did that. And the high dose of oxalic acid, it decreases the survivorship significantly different compared to sham. So now, what is new in these results are what is the survivorship in the second year. This assessment was done last week, and we have the different treatments and the percentage of survivorship. So now, after we focus on having stronger colonies by the fall, we observe that 30% or 30% of the colonies have died so far. So 70% of the colonies are alive. The survivorship increased with Amitraz, but also with the low dose and the medium dose of oxalic acid. This indicates that the one factor that is crucial for colony survivorship is colony strength. And as we expected, high dose of oxalic acid decreases the survivorship. In this slide, I am showing only the data from Saskatchewan, and the data of Manitoba is in its way. So with this, what we can conclude? That the new formulation of oxalic, well, first, is that the winter is a great opportunity for treatment. And as I mentioned, because there is less brood in the hives, and most of the mites are on adult bees. However, there is a challenge for the beekeepers to access to those hives because, for example, right now we are in the middle of April, and tomorrow we are going to get snow, actually tonight. So accessing the hives in the winter is difficult. And if the beekeepers are using colonies indoors or keeping the colonies indoors, it's challenging to operate or to open the hives inside the building. Oxalic acid glycerin strip is effective, and the mite levels go below the threshold, which is 1%. The safety of this product will depend on different conditions or variables. First, the dose. Higher the dose is less safe. The colony conditions play a relevant role on the safety, and also the time of application, the amount of application. Amitraz is still effective against mite. And what else we are doing at the University of Saskatchewan? Well, we are conducting more research during the winter. For example, applying oxalic acid vapor in colonies that are outdoors, and using oxalic acid dribble mixed with sugar syrup in indoors. So with these results, just to grab up, I don't want to promote just to leave the strips there for all the winter. Just follow the guidelines and the label of the product. And this product, the Varroxan strips, the intention is to be used in spring, summer, or fall. So using this product or these strips in the winter is what we are testing, how safe is for the bees. And now I would like to say thanks, and I would like to pass to our next speaker, who is Lynae Ovinge. Thank you.
Thank you, Alvaro. I need to go back. Yes, so I'm here today because I work as a consultant in the beekeeping world, which sounds kind of fancy, but really I just wind up doing a lot of Varroa trials. I do them for beekeepers. I do them for companies trying to register Varroa, and so because of that, I was also able to get a contract from Canadian Honey Council to put through this amendment to the oxalic acid label, which we've been talking about all night. But so the oxalic glycerin pads were added to the oxalic label. And yeah, this just went through this year, and been many years of work by a lot of people in Ontario, and the other trials you saw tonight, with the exception of Alvaro's, which is too new, were used to support this registration. So lots of people led up to this, and then I was the one who actually sent it through. And so I just wanted to use my time to explain to you a couple of little things about the label. So this part is all the same. And obviously, I just want to say, you guys, almost all of you, I'm sure, know this, but there is PPE, personal protective equipment, required when you're mixing oxalic acid or applying oxalic acid, and particularly for the glycerin strip. We have this heating element that we've never really been done when we've used oxalic acid before. So here's the whole label. Now, I'm not sure how this will show up for you guys, but what I really want to show is that here's our solution method. So this was on the label before. This is an old label, and these parts of the label are actually very vague. But so this is your solution method, which you guys will call dribble or trickle usually. Here's our vaporizer method, which is widely used. As you can see, it's really, really vague. And it's just an old label, and that's why it's that way. It doesn't say anything about, say, the temperature, which we know is important for oxalic vapor, or like multiple applications, which are things that have become part of how we use the vaporizer method in Canada. But so yeah, these labels these parts of the label are more vague. When we get to the glycerin strip method, it's much more detailed because this is an amendment to the label, but so it's a newer section of the label. And so there's just a few things I want to highlight, okay? And one of them is that we've written here that this is for suppression of Varroa mites. And as some of the previous studies mentioned, the efficacy of this treatment is very variable. So by using the word suppression, we're saying you're not going to get this really fast knockdown of all your mites. This isn't your fast acting treatment, but it's useful for suppressing Varroa mites. And as they've also mentioned, it can be used with brood and honey superzon. Now, there's lots of detailed instructions in this label, but I want to highlight what is not detailed because I think it's really important, and I purposely made sure the label was this way, but there is a ton of leeway in the material you use for the homemade. And that is really because this homemade thing has developed naturally over time, and we've seen that a lot of the different studies use different strips. We know, just talking to beekeepers, they're using different strips. And so the label's written in order to that you can basically use whatever strip you want, whatever size it is, as long as it's absorbent, and that you make sure you're doing the 50 grams per hive, which is written down here. And I think this, and then in the next section here, you can place them however you want. So they can go over the top bars of the brood chamber, or they can be allowed to hang down between the frames. So, and then it does say they should be left in for 42 days. But there is a lot of leeway in the particular strip, and this was on purpose, but I really do think that as we move forward as an industry, now that we have this registered, that we'll get a lot of extension work and try to figure out, what are the advantages of these different materials we're using. And basically, I mean, really what we want is to get the dose to the bees and to get the maximum number of bees walking on the strips, right? And so how does that relate to pad surface area and where we're placing the pads and that kind of thing? And so in this way, this label allows kind of for adaptation as we move forward, which I think is really important. And if there's one thing I know doing this work is that the beekeepers will adapt, and they'll, right now the green pads are the way to go for a lot of guys, but I think we'll see it move forward, and we'll really get this honed down, what's the most effective way to be using this. So I just wanted to highlight those things, and give again a shout out to the other studies that were involved here. And yeah, and if anyone has any questions later, happy to answer them, and I'll just hand it back to Matthew now. So.
Hello. Okay, so I'll ask Brad to bring all of the presenters on the screen. Yeah, there's been a lot of wonderful information, and you guys all did an excellent job of putting it into a very short time period. I think I talked way too long off the bat, so I definitely commend you on that. I will be rewatching this webinar to take more of it in. During this time, I've also been monitoring the chat. We're receiving questions from all the different channels, and there's some good conversation going on in the chat. I'm just going to start with Lynae since we ended on the label. There's a bunch of questions, Lynae, but I think, okay. One of the ones that someone has asked me now a couple of times is, why is it said on the label to not use leftover oxalic-acid glycerin mix? So you're making up your strips, you mix your batch, and then you have a bit of leftover at the end. And what does that really mean by leftover? Is that by 1 day? Is it by a week? Or is it by a month? What's the concerns here?
Yeah, I think like we can't have anything on the label that we don't have data for, right? And I think we had a limited amount of data to push this through, and we got it through. So I can't really put something on the label. Oh, by the way, you can reuse this solution for 60 days, but not 120 days, or 2 days, but not 7 days, without having the data for that. And I think we all agree that if we'd waited around for the data for that, you know, that would have slowed things down. If I can just answer on a similar line, I saw in the chat, someone was asking about singles versus doubles because, you know, the dose was the same. Again, all of the trials were done on singles. So we just don't have the data for saying, you know, double the dose on doubles, which I'm just going to point out that I really don't believe that doubles are double single, or, you know, I don't think they necessarily have twice the bees of a single when singles are ran by really good beekeepers who are running exclusively singles. I don't believe they magically have half the bees in them. That's a side note, but we just don't have data for doubles. No one does Varroa trials on doubles in the whole world, really. Maybe in Canada a little bit, but so there's just not data on it. Again, we can't make a case for something when there's no data, so we just say, yeah, the dose is the same for both of them.
Okay, I know this is on the label somewhere. I'm not sure if you remember it, but just the question I had earlier, I know it is on the label. Is there a shelf life for the make it your home products and the storage recommendations?
I think it says we use within 1 month.
Yeah, I think
I have to bring it up again.
Close
Yeah.
to the...
And that just seemed like a reasonable suggestion that I think most beekeepers would be able to remain compliant with that.
Yep.
So.
Okay. Yeah, no, I liked your point that now it's here. A lot of people are using it, figuring out what works best. And there's a lot more extension work that could be done to help us adapt. Yeah. So I did want to go back all the way to Laurence at the beginning and ask and I have a couple of questions for everybody. So these are questions that they're not my great questions. These are the questions actually I've been pulling from the chat. So trying to get everyone in here, get these questions answered. So firstly, Laurence, I definitely appreciate the point that, you know, even if you're getting a 40% efficacy in some cases, this could mean thousands or hundreds of mites. And so it's not nothing, and comes back to Nuria's point about working this into your toolbox and don't stop strategizing the different tools you're going to use throughout the year. There was a question in the chat that was wondering about the reduced weight gain that was observed. There was no impact potentially on the bees or on the brood, and I noticed that the treatment period was quite short. I think it was 3 weeks.
Yes.
So what do you think was going on possibly here? Could this have been someone suggested a function of reduced foraging, or what have you guys thought about?
Yeah, we hypothesize that maybe it will be kind of a bigger surface on the top of the brood chamber, maybe the movement of the bees or trying to not touch the pads, but we didn't find any perfect answer to that result, honestly. So yeah, and we also weighed the wall hive, so we didn't just took the honey super. So we kind of interpret this by honey super but it's the whole hive that were weight. So yeah, kind of a weird result, and we didn't saw the same thing in the literature, so it was kind of the opposite. So we don't fully understand that result, fortunately.
It's definitely something to be, be cautious about. And I think, I don't know if how much how critical it is to start looking at, but I'm interested in if there could possibly be any reduction in our honey production, because at least here in the prairie provinces, we have a very short season, and it's all in one stretch to produce our honey, and if we miss it, it's done. So it's definitely something I think merits more research, if there is any impact on honey production. Which kind of ties into the next question that I saw in the chat for Nuria, which was about this potentially spotty brood pattern. Well, firstly, my concern is, of course, if I see a spotty brood pattern, and it takes 45 days to recover, that could really slow down my population growth for collecting my honey crop. But the question was, why would brood be spotty if the queen and workers aren't affected? So do you have any?
Yeah, absolutely. Thank you. And great question. So it would be most likely because the strips are hanging on the frames, and these don't like to have things. Well, you have a acid, a smelly chemical right there near the brood. So even when you put a anidress or an apivar strip, they tend to stop laying eggs, and you see like a mark on the wax. So that could be related more of a physical contact of the chemical. And yes, the recovery days is 45 days that were noted. Now, this study did not assess the impact on honey production, but looking at the cluster size of the colonies, there was no impact noted on population or on mortality. So these are quite resilient. So there might be ways for them to overcome that disruption. And this was just a personal mental note, but I was wondering if that disruption on brood production was also helping disrupt the mite cycle and helping with this the efficacy or that we see with the products.
Okay. I do want to maybe go back. Just one question that somebody asked here in the chat for Laurence was, based off your studies, did you have all three treatments at each of the apiaries? Oh, here we go. Brad's got it up on the screen. So did you have all three treatments at each apiary, or was one site having only this treatment and only that treatment?
Yeah, all treatment were in all apiaries mixed. So probably everywhere in the apiary, and the frequency, it was only one application, so 3 weeks period from the beginning of August to kind of end of August.
Okay. Yeah, and I just and I guess, Nuria, going back to your comment about how strips interact, I was watching a video the other day, and Randy Oliver was demonstrating, how that, beekeepers notice with strips sometimes that kind of sunk in the wax chewed away, and he was asking himself, is there any type of benefit that maybe the bees were then going in between and rubbing against the strip and also moving that around. And now I've heard from people out in the field that they've observed that in their colonies with that kind of marking and disruption, and then other people claim that they haven't seen it. So it's quite interesting to follow up. Lynae, have you heard any feedback on that from your beekeepers?
I'm sorry, I was reading the comments. What?
I know there's lots of people.
Aspect?
No, about if the strip is disturbing the pattern, or there's a chewed away wax or stuff like that, and if it's an issue, beekeepers find it to be an issue at all, or they don't mind.
Well, I mean, we all know Apivar does it, and we've been happy with it for a long time. So, most of the ones I know more haven't been hanging between the frames. But we'll certainly see a lot more of that now with Roxanne. So I guess we'll have more answers soon.
Okay.
Mhm.
Alvaro, I do have a couple questions for you. Luckily, I've been fortunate to be collaborating with you and Dr. Sarah Wood, so I have a little bit of inside knowledge on this trial. Yeah, so now I'm thinking, where do I start with this? My perception has been that when you've been doing your sticky board counts, you've put in the strips, or we've put in the strips when the colonies are, fairly broodless. And when you've done your sticky board counts, you're seeing a pretty fast knockdown. Is that correct?
Yes, it's correct.
Yeah, so really related to that broodless period versus in presence of brood when most of these people are using it. So it's definitely not, it's definitely not false to say it can provide a fast knockdown, but it depends on what's going on in the colony. It sounds like how much brood is there and how the bees are moving.
Exactly. As used to mention, in our study, we applied the treatments for 8 weeks. The most number of mites that we observed on the boards were during the first 4 weeks, but mainly the first and second week.
Okay, yeah, that makes sense. So we noticed that there was a reduction in survivorship in some of the, especially the high oxalic groups from the indoor wintered colonies. Could you tell us a bit about your ongoing work that kind of looks at both indoor and outdoor colonies? Are you looking to see, is there going to be potentially, like, is that something you've done already or are planning to do, to look at the impacts on outdoor colonies versus indoor, and whether there is a great difference between how these treatments are impacting survivorship there?
Yes, for the data that we already have for this project, the Varroxan project, I can see that depending on the colony conditions is the effect on survivorship. For example, with Bill, with you in Manitoba, his colonies were really good. So the impact of survivorship was higher than the colonies that we had last year in Saskatchewan indoors. But following your question about the other projects that we have with oxalic acid, so far, what the preliminary results we have is that oxalic acid, yes, is toxic to the bees in the winter. One study that was done by one master student, Emilio, from Sarah's lab, he applied oxalic acid in the summer, and he did several applications, and no effect on toxicity on the colony. But now another master student, Serhi, he is doing that indoors, and he has observed higher mortality. In terms of the other project, the oxalic acid vapor, yes, depending on the dose, the colonies are dying with higher dose, and actually with several applications. But we are still analyzing the data, and those projects are still ongoing.
Yeah, and I guess I should just highlight what we call high dose in our winter experiments is actually a regular dose through the rest of the year.
It's correct.
Yeah. So we're saying a high dose is harming some colonies, but just so beekeepers are aware, that's actually just a regular 28 gram per brew box dose, but in a different setting in the winter.
Yes, and just to finish with my comment about that question, for a reason, we can see that the impact of oxalic acid on winter bees is worse than on summer bees, but we need to analyze more data.
Okay. Wonderful. Lynae, you've been monitoring the chat. Are there any questions that have come up that you want to address?
Yes, I'd love to answer Julia Coleman's question, because I love her, and we didn't have the experience of having her in person, I guess. She asked for an example of how this is actually being used without other treatments in the year. So I'll say, well, I know a beekeeper nearby with a lot of hives does Apivar around March 15th to April 1st. Puts on these pads, oxalic acid pads, the green ones, which is a Swedish sponge, around May 15th to June 1st. And then Formic Crow around September 1st. Then oxalic vapor, and I'm in Lethbridge, so this is Southern Alberta type weather, but oxalic acid vapor, like 3 rounds, all in usually October/early November. So that's just an example of how it fits within a treatment regime that's currently being used.
Well, thank you for that. With the Formic Pro, do you know if it's a 1 pad application or 2?
2.
Mm.
2 pads on a double.
Oh, on a double.
There's been a lot of talk also about the pads in between. Like, so when we're doing pads on a double, I've got some beekeepers who want the pads in between the 2 brood chambers, and some beekeepers putting them on top of the 2 brood chambers. And it's kind of some thought, we always want the bees to go up into the super, and so there's some thought that maybe the pads above the second brood chamber would slow down bees going into the super, especially beekeepers that use no excluders, which is pretty common. So we hear some chat around that. I don't know that one's ever been finally resolved, but some beekeepers feel that it's better to put the pads between the 2 brood chambers to avoid any risk. And someone else asked about the strips next to the excluders, like on a single, for instance, if you put the pads on top and put excluder on top. I've seen green excluders from the pads, but and you would think it is corrosive to metal, but I haven't seen anyone shy away from metal excluders for this reason. So.
Okay. Alvaro, I'd like to go back to you and ask about the mid dose. Did you see good efficacy with the mid dose? We know the high dose killed mites, but it also appears to be harmful in the colony. A mid dose was 2 strips, I believe. Was it 3?
Yes, 2 strips. 2 strips.
2 strips. Did you see good efficacy on mite kill?
Yes. Yes, in both in Manitoba and in Saskatchewan, in both years, we had lower mite infestation compared to sham. So yes, the efficacy was high.
Perfect. Yep. There's maybe a tough or impossible question, but I'm going to throw it your way, everybody. The question is about using oxalic acid strips with other types of treatments. I've received this question in a number of different ways. The first time I received it at a convention recently was, what do I think about putting in the oxalic strips, but also doing vaporization at the same time, because maybe I'm there or I want to get a quick a drop and use a long slow release, as well as get a couple flash drops in. But I think what a lot of people are talking about is what else can they potentially use or not use it in combination with? Is there something that they should be particularly concerned about using it in combination with? Formic, Amitraz, yeah. Does anyone have any thoughts? I know it's a really difficult question.
I think, if there's gaps in our knowledge of Varroa treatments, it is this. there's no studies that really tell you about the safety of them being used at the same time. And I think a lot of beekeepers assume that maybe using them at the same time they get double the kill, but it really does depend on the mechanism of that particular Varroa side. And also, it's also possible that they might sort of not work well together, and they could cause effects that neither of them cause separately. I do think I just speak for what I see in Alberta here, but there's this changing landscape of Varroa management where it's becoming incredibly hard to control, especially when you start to see apivar resistance or amatraz resistance. And so I think answering those questions about which of these treatments can be used at the same time is important going forward, as we see Varroa become more and more hard to control. So
I can also try to answer that question. In your first point, you mentioned applying the strips and at the same time applying oxalic acid vapor. I will not go with that because in the experience that we have seen so far in Saskatchewan, regardless the way of applying oxalic acid could be in sugar syrup, the strip, or the vapor, it harms the bees so far in the winter. So applying two different ways the same product will be, in my opinion, will be harmful for the bees. And in addition to looking at different treatments, as Nuria mentioned, integrating a pest management strategy. So maybe looking also for breeding programs that can help to have bees that are more tolerant to Varroa. Thanks.
I guess I'll make a call out for any last words from any of our guests. If there's something you want to comment on or share that you haven't had a chance to.
So I would just mention that it's exciting to have a new method for controlling mites, and we should take advantage of these, try it out, and I would say never trust the mites. So keep monitoring and let us know what your experience is, because that helps to make informed decisions, and on our side to know what to research, and we can take the losses for experiments. So let us know. And thank you to the organizers too.
Yes,
I think,
sorry.
Oh, sorry. Go ahead.
I just want to say thank you for the invitation. That was a nice webinar and nice to also learn about your project.
I think this is a great example of beekeeper innovation that really needs to be applauded. In some ways, I think this is one of our biggest advancements in Varroa control in the last 20 years, and it's mostly was very much driven by beekeeper science to begin with, right? And so those beekeepers who share with us their findings about this so that we're as aware as we are right now, that's really great. And just continue to please tell us what you find, because no one is better at finding new treatments than beekeepers, in my opinion. So, and thank you all for joining.
All right. Yeah, no, thank you all for participating, and lots of good conversation and questions in the chat. So I'll try to inform everyone when we get another webinar presentation going on. But no, yeah, wishing everybody a great evening, and thanks for tuning in.